Hello everyone. Good evening. Welcome to the new session of Docker and Kubernetes. So before we go into the Docker and Kubernetes, so I just want to tell you, welcome to DURGASOFT. And here, what we are going to discuss is that is cloud-related Docker and Kubernetes. So totally the sessions will be on AWS, like on the AWS cloud. What are the Kubernetes sessions that we are going to take? But don't worry about that. So yes, and I want your introduction, and then we will go into the concept. So before that, let me help you with myself. I am Chaitanya. I will be the trainer for you in the next couple of like 40 days of the sessions. So is it going to take that much amount of time? Of course. So why? Because the syllabus is very vast. So definitely it is going to take so 40 days of time. So, and when you come to my qualification, currently I'm working as a senior DevOps engineer in a reputed company, MNC company. And previously I worked as a senior system administrator, and where I used to work for them hundreds and hundreds of servers. And from the system administrator, I started working as a DevOps engineer. Okay, so yeah. So, and if you see my certification, I'm a Microsoft certified, I'm a Red Hat certified, and I'm a Kubernetes certified. So totally, I am completely into the system administration background. So which means that I am totally working with the servers. Okay, so that's about myself, and I am having an experience of 13 years. So starting from 2010 onwards, right now going on. So previously I used to work for ICICI Bank, and now I am working for a top-notch MNC company in Bangalore. So that's about myself, and you can tell me about yourself and what are your expectations towards the classes, and then we will go one after the other. I hope I am audible to you all.
Yes.
Yeah, tell me. So what's your expectation towards this course, whatever you are about to study? And then what, so do you have any prior knowledge on cloud, any cloud? It is not about the AWS, it is not about the Azure, any cloud. If you have any experience, you can tell.
Yeah, I have familiar with the Docker partially, but I don't know the in-depth knowledge of Docker things. Okay, we just learned for few commands, but we need to know the end-to-end Docker concept. Kubernetes, we very zero knowledge on Kubernetes part. We need to learn end-to-end part of Kubernetes as well. But and you said we need to use, we will be using an AWS EC2 instances for the Docker, but will it be chargeable for the usage of the service, and how may it get charged if you use it?
Yeah, of course, it is chargeable, but not heavily chargeable. I will tell you how much it is going to charge for you whenever we dive into the concept. Okay.
Okay. And whether do we get a recording of the session of this?
Everything. So that I will tell you. But as of now, what's your qualifications? Are you working or else are you studying? There is no. So there are the children who are. I'm talking about the children. You might be a working professional. There are some people who are just completing the education. They are also starting their career.
Hmm.
So it's not like only professionals are joining in this course. Everyone are joining in the course. So the course is for all. So only one thing that you need to understand here is you need to have a basic understanding about the Linux operating system. We'll discuss about that. But before I dive completely into Docker and Kubernetes, what is Docker? So today's our entire session will be Docker and KATS, Kubernetes. So why it is called as KATS, we will discuss about that in the later part of our discussion. So, but now what we are going to discuss here is how we are going to work with the Docker. What is Docker? Every now and then you are hearing about the Docker, right? So now what is that Docker? So Docker means it's a containerization platform. What is meant by a container? So here the questions will alternatively generate from one after the other. So Docker is a container platform. Now the question occurs, what is container? What is container? Now, when we are discussing about the container, then obviously why container? Why we require? Why we need to go for the containers? First of all, in the first place, why we have to go for the Docker? So what we used to have previously, we used to have the servers. Then from servers, why we are going with the containers? So this interaction, this interconnection, you need to understand. Yes, we will discuss about that. But before we dive into the concept, yeah, I want the other people to discuss about this. So just introduce about yourself, and if you have any experience regarding the Docker and Kubernetes, or else what is your profession, you can let me know about that. Guys,
Like I am Chetan, like I have overall 8 years of experience. I was in Python development,
fantastic.
only into Python backend development.
Super.
Yeah, like in I have worked upon Dockerization of part and Kubernetes part. Like I haven't worked, but in my current company, we were asked us to work upon the Kubernetes as well. We have an use case to work on Kubernetes as well. So that to get an one-to-one interaction and hands-on learning, I joined this course.
Fantastic. And now my another question is, you are working with the Docker. What are the technologies that you have worked? Like what's your opinion on Docker? Now you said that I'm working on the Docker. So how you are working?
Like and we didn't develop a much a complex application in my previous. Okay, we just moved an entire application into a Dockerization. We created a base image from Ubuntu base image. We installed some packages. We installed some pip install packages, and we were run the application. But it was not a kind of microservice based installation with the
Okay.
cross container communication was not there, but it was just a basic Docker build with a single application installed on that one.
Okay.
But there are a lot of commands in there in the Docker. Still, okay, still I'm not familiar with that use case
There
of
are
it.
lots and lots of commands are available in the Docker. We will go ahead and
Yeah,
I will make you understand about what is what and how we are going to work
yeah,
around with the Docker. Not
yeah.
only a single command, there are lots of instructions are also available for Docker. We'll discuss about the Docker images and everything. Okay. In
Okay.
this session, what we are going to discuss is totally about the Docker images. Okay. So what we are going to work, we are going to work with the Docker. So mute yourself.
Okay. Okay.
Mute yourself, Chetan.
So sorry, I missed the context. Hello. Hello. Hello.
Yeah, I'm sorry. I just lost my internet connectivity. Yeah. So previously, why we are actually going with the containers? What is the necessity of going with the containers? Without containers, can't we survive? Or else, first question is, without application, can't we survive? See, whatever the applications we are working out, all the applications will be created by the developers. Applications will be created or developed by developers. Either it might be Java, or else it might be Python, Ruby, Golang, like that. There are so many other languages in which the applications are going to be developed. Now, when the applications are developed, and these applications will not directly go and interact with the users, the end users. So what should be happen? There are three-tier architecture is there. Web three-tier architecture, we will call it as. That is the web tier, and the next one is app tier, and the next one is DB tier, that is database tier. Now, when we are discussing about the web tier, what is this web tier? This is the web application. Okay, so the front end UI, I can call it as an UI, UX. Okay, so the web tier is nothing but the internet page, or else the browser page which you are looking after. So that web tier will be interacting with the users. So that is why it is called as an user interface. And whenever the user requests anything, like when he gives a username and password, or else he can provide something, request like I want this product, that product, like that. So that request will be forwarded to the application type. So in the application type, you will have the apps that are created by Python, Java, and so on, Node.js, .NET, like that. There will be so many things. Now, in the database tier, you will have the actual data stored in the database. So you will have MySQL, PostgreSQL, MS SQL, like that. You will have so many things. Okay, so these are all comes under the DB tier. Now, now whenever we are working with the containerization, but before we go into the containerization is the word which you are hearing from the past few decades. Okay, past few decades you are hearing the word called as containers. Okay, not about the decades also, I can call it as like 2014. From there only you are hearing about the Docker, containers, and Kubernetes orchestration and all the things. Before that also they are there, but they are not that much popular. Okay, so what we used to have before 2014. So like if there are any web applications are there, websites are there, how they are going to create those website or else web applications. So to create that, so we used to have a server. The system administrators will be given with a server. So in this server, you will have resources. Okay, so you will have the resources. What are the resources? Resources are nothing but CPU, RAM, storage, and network. These are all comes under the resources. These are all comes under the resources. What are the server resources? Server resources are nothing but CPU, RAM, and storage. These are all comes under the server resources. So every device will have this resource configuration. Depending on that, we are going to install the application. First of all, what happens whenever the company requires to deploy their applications or else install their application, they will go to a particular vendor. Either it might be Dell, HP, Lenovo, or else any another thing. Okay, so they will go to a vendor, and they will get a quotation from the vendor. Why? Because they have to purchase a huge equipment. Servers are not generally like your computers or else our laptops. So servers are very huge. So if they want to purchase, they have to get a quotation from the Dell or else any service provider. So they will get the quotation. The company will get, they in the sense the company will get the quotation from the required users. Okay, so after getting the quotation, they have to install. They have to, in the sense, the organization has to install the server in their organization. Okay, so to install that server, they will keep the server in the data center. Like there will be a separate room for that. Inside the room, they will keep the servers, and they will start running the servers. But after starting the servers, first of all, what is the requirement? If you want to start a server or else if you want to install any application, what are the requirements? See, if you want to have the application installed, you need to have the operating system. Without operating system, is it possible to install any application? It is not possible. So we will install an operating systems on the server, on whatever the new server that we have purchased. What we will do, we will install the operating system. Okay. So this is my new server and I am going to install an operating system. In the operating system, either it might be Windows or Linux or else what I can say Unix, Sun Solaris, any server, Debian, Ubuntu will also comes under the Debian, Red Hat, CentOS, SUSE, Linux, like that. There are so many flavors of Linux are available, and as well as the Unix, IBM Unix, or else what else you have, Sun Solaris. These are all comes under the Unix, and Windows Server 2019, or else hypervisor, any sort of operating system you are going to install on the server. So once you have installed the operating system on the server, now what you have to do, you have to run the applications. Okay, so whatever the web 3-tier architecture that you are seeing, I will install all the web 3-tier architecture on the server. So the front end might require a different CPU and RAM configuration, and the remaining applications will require the different configuration. So this physical server, whatever the physical server that you are seeing, it is having some 16 CPU and some 256 GB of RAM. With there is a concept called as SAN, storage area network, of certain like 4 terabyte size of storage is also available for this server. Okay, so like that you have configured the server. So once you have configured the server, you install the operating system, either it might be Linux or also anything else. So, and later you are going to install the applications. So that is the web application, the front end. Okay, UI applications in the with the help of Tomcat or else Nginx or what else you are having Node.js. With the help of these front end tools, you are going to install or else you are going to run the UI. So to run these applications, you require 2 CPU, some 4 GB of RAM or else 8 GB of RAM. And for the next one, application server, you are working with the Python or Java, or I can go with the .NET, especially .NET is for the Windows. So to run these applications, your server or else this application may require the resources like 4 CPU, some 32 GB, 32 to 64 GB of RAM, for example. And in the backend, you will have the database where best one is Postgres or else MySQL, MS SQL, Oracle, like that you will have all the databases. So this particular database may require somewhere like 8 CPU, 128 GB of RAM. Okay, 8 CPU, 8 CPU, 128 GB, or else in general 64 GB of RAM. Okay, so that's more than enough. Now if you can see here, all the applications are running in a single server. In general, when you are working in the companies, this is not allowed. In general, whenever you are working in the companies, this is not at all allowed. Okay, so in a single server, you need to run a single application. You cannot run all these applications in the single server. But to make you understand, what I have done here is I have allowed all the applications to run in a single server. Now, if you see the total resources will be 14 CPU and only 132 GB of RAM. What about the rest of the resources? The rest of the resources will be useless. They are not going to use. If there is a peak load, so at that particular time only the resources will be utilized. Yes or no? So to overcome this problem, so what is the problem here? The resource optimization is not happening. The entire resources are not getting consumed. At least 80% of the resources should have consumed. But here we have left out with a certain 128 GB of RAM. So which means half of the RAM is not at all utilized. So what we have to do? So what about that resources? Is this server is useful? So this server is useful only to run those specific applications. Apart from that, if you want to install any new application, it is not compatible for that. So now what I have to do? So this server will be, the resources will be misutilized. So to overcome this problem, so IT industry has came with a new thought called as virtualization. Virtualization. What is this virtualization? Logical division of your servers. Okay. So am I with you? Are you following the concept here? What we have discussed now until now? Anyone? Before I dive into the next one. Guys, are you with me? Hello, am I audible? Are you with me? Are you able to understand what I am saying you here?
Yes.
Okay. So we are
Yes.
about to, okay, cool. So we are about to understand the virtualization concept. Whatever you are seeing here, these are all the physical servers. We discussed up to now, whatever the server that we are discussing, that is a physical server. It's a physical entity. So what are the main basic problem with the physical servers is that network management, storage management, everything has to be taken care by the administrator only. Okay, so next one is virtualization. So, and one more thing here is, so whatever the physical server that you are seeing, this physical server will have a different version of operating system, and the developer, whatever the client mission that he is using, he will have a different version of operating system. He will have the client operating system, and the server will have the server operating system. Some modules and some what I can say, some modules are compatible with the client operating system. Some may not be compatible with the server operating system. So there will be a conflict between the administrator and the developer, saying that the application is not running on the server. So the developer will say that in my computer it is working fine. So obviously there will be a conflict between the administrator and the developer. So what we have to do here? So to overcome all these problems, whatever the problems that are faced here, to overcome all these problems, we are going with a specialization concept called as virtualization. So what virtualization will do? So virtualization will divide the server into logical servers. A single physical server will be, physical entity will be divided into logical entities. So for example, if I have to show you, let me show you one thing. So actually this is my Windows 11 mission. Whatever you are seeing here, this is my Windows 11 mission. Okay, on the Windows 11 mission, what I am going to do here is I am installing Windows 2000. So a client mission here, and I can install the Ubuntu mission. I can install whatever I want. So from where they are consuming the resources, I have given 4 GB of RAM and 2 processors and 64 GB of hard disk. From where they are consuming here is, if you see my laptop resources here, what is my laptop resources? What are my laptop resources? Here you can clearly see that it's a 32 GB of RAM and it's a 3 gigahertz processor and normal, so 500 GB of hard disk. From these resources, this particular machine will take the resources, which means that the CPU or RAM will be collected by this machine from my base machine, which means that it's a virtual machine which I am creating right now. So tomorrow I will show you. I will install the Ubuntu machine. I can run the Windows 11. I can install the Windows Server 2019 like that. I can install whatever the virtual machines that I want. So as of now, this is how the virtualization will help you. So virtualization means logical division of your entire server into small servers. So whatever the server that you are seeing here right now, that server is having, as I said you, 16 CPU and some 256 GB of RAM. That will be divided into, so with the help of virtualization concept, that will be divided into small logical servers. Those are called as virtual machines. So this is VM1, VM2, VM3, like that. We are going to create multiple virtual machines. In each virtual machine, we can install whatever the operating system that we want. Either, for example, in this virtual machine, I want to install the Linux, that is RHEL. I can install that. In the another virtual machine, I am going to install Ubuntu. I can install that. In the another virtual machine, I want to install Windows, I can install that. In the another one, IBM Linux or else IBM Unix. In the another missions, I want to run the Sun Solaris. Okay, in the another vision, I will go for Windows client, that is Windows 11. Okay, so all these virtual missions, whatever the virtual missions that are created, all these virtual missions will gather the resources, that is CPU and RAM from the server. So they will communicate with the virtualization software. These virtual missions will communicate with the virtualization software. This virtualization software will communicate with the server. Okay, so it is going to communicate with the server requesting for the resources. So if the server is having the resources, it will allocate. If the server doesn't have the resources, it's a dynamic allocation. It is not a static allocation. What is dynamic allocation? The dynamic allocation means, so what is happening in the backend means, for example, this server, we have allocated 4 GB of RAM for the RHEL server. Try to understand. 4 GB of RAM. So here on the server, I am having some 256 GB of RAM. Now what RHEL will do here is, initially it will take 2 GB of RAM only, even though we have provided 4 GB of RAM. Initially it is going to collect 2 GB of RAM only. Why? Because the minimum requirement for RHEL server to install is 2 GB. So it is going to collect 2 GB from 256 GB. Sir, what sir, you have given 4 GB, still it is collecting 2 GB? Yes, it is going to collect only 2 GB. And later when the applications are installing, then automatically the size will increase. Dynamically the size will increase from 2 GB to 4 GB, and later on we can increase it to 8 GB, 16 GB also, depending on our requirement. So suddenly we can increase, on go itself we can increase the RAM resources, but CPU resources we cannot increase that. So dynamic allocation will be there in the virtualization. So this is the main benefit of the virtualization. So previously when you see the server, if the load on the server is increased, so I'm having only one server. Okay, so this application is entirely consuming the server. So now what I have to do, I have to purchase another server. I have to purchase another server and I need to install that. So which means that it is going to, so it is cost effective thing. Okay, so more cost will be involved into that. But when you go to the virtualization, but if you go to the virtualization, if the server load is increased, automatically we can create a new another server. But it is going to take a lot of time. Why? Because we have to install the applications, we have to install the operating system and everything. So we have a problem with the virtual machines. Even though the virtual machines nowadays also we are using the virtual machines, whatever the AWS EC2 instances that you are seeing, all the EC2 instances will come under the virtualization platform only. All the EC2 instances will be the virtual machines only. Okay, so now then why we are going with the containers? What is the necessity of going with the containers? If we have the virtual machines, that is more than enough. No sir, then why we are going with the containers? Do you understand the concept of virtualization? Anyone, guys? Hello.
Oh, yes, we understood.
Right, so that's the main point of your virtualization concept. So then why we are going for the containers? What is the necessity of going into the containers? The main point behind the virtualization is to optimally using the physical resources, but it is a heavy weighted image. If I want to transfer the image from, if I want to transfer the server from product development environment to the production environment, it is a it is a time taking task. Within seconds I cannot transfer the image, within the seconds I cannot create the image, within the seconds I cannot move the virtual machines from my development environment to the production environment. So I want to make it very light. Why it is heavy? Why the virtual machines are heavy? Because it is because for the virtual machines we need to install the operating system. So virtual machines will not quietly come like that. So what we have to do here is, for virtual machines also there will be operating system. Okay, so you are going to create a VM. and on the VM we have to install the operating system. A separate operating system has to be created. Inside that we have to create the application. Okay, so this VM is created in the server, in the physical server. So if you see, this is the physical server. Inside the physical server we have a VM1. So inside this virtual machines we have to install the operating system. So that is, for example, Linux. So the Linux operating system itself will take minimum of 8 GB of storage space. Inside that we have to run the application 1. So I need to create one more virtual machine in, for example, in the Windows operating system. So Windows operating system minimum it is going to take some 30 GB of space for the operating system itself. So that is why they are heavy weighted. So to overcome this problem, we are going with the concept of containerization. Containers are less weighted. So here you can see the application will communicate with the guest operating system. Whatever the operating system that we install in the virtual machine, they are called as guest operating system. And if we install any operating system on the physical server, then that is called as a host operating system. Okay, so if any operating system is installed on the server, on the physical server, try to understand, on the physical server, if we install any operating system, then that is called as a host operating system. If you see here, my Windows 11, whether it is a guest operating system or host operating system, you see the my Windows 11, whether it is a guest operating system or host operating system.
Host operating system.
Yeah, it's a host operating system. Okay, so why? Because on the top of that, what I am trying to run the virtual machine. On the top of that, I am creating a virtual machine and running the operating system. So that's the reason it is called as a host operating system. The operating system which we are working on the physical server, then that is called as a host operating system. And the operating system which we install on the virtual machine, then that is called as a guest operating system. So the application will communicate with the operating system kernel. So do you understand what is meant by kernel? Do you know what is meant by kernel? Yes, anyone? Do you have any idea about the kernel? Okay. Do you have any idea about the interpreter, mediator? Okay. So it's a basic question which I am asking you. Very, very basic question. What is an operating system? Even 6th class guys can say about this, but I am not commenting on that. So if you know, tell me. What is an operating system? Yes, guys. What is meant by an operating system? I got a response. It's a software to communicate with the hardware. Okay, fantastic. So an OS is a software to communicate with hardware. It's very good. Is it so?
It
Now, if
manages the resources, scheduling. It takes a lot of functionality like an
very good.
resource
OS will
allocation.
manage the resources. Very good. But in general, what OS will do here is, for example, this is your computer hardware. That is CPU, RAM, hard disk, and everything. Okay. Now, if the user want to execute certain command, so this is the user who is interacting with the operating system. For example, there is a user. Okay, this is the user who is interacting with the operating system. Now, my question is, he will give a command to the OS. He will give a command to create a directory or else to store a file. Okay, image file, audio file, video file. He will communicate with the OS. So what OS will do? OS is not a direct interaction with it. Is not going to be a direct interaction with the hardware. Okay. So who will do the direct interaction with the hardware in the sense? So in between user and the hardware, OS will be there. But but in between OS and the hardware, in between the OS and hardware, you will have the kernel. So this is very important. This kernel will interpret, or else this kernel will compile the OS requested data to the hardware. So the user, whatever the user is requesting, user will say that new folder. If you see in the Windows, I simply go with clicking on the new folder. New folder. Okay, when I click that, automatically a folder is created. Okay, so now my question is, when the user gives an instructions, OS will understand, and OS will forward that request to the kernel. So who will manage the resources? Not the operating system, but actually the kernel will manage your entire resources. Okay, either it might be memory allocations, it might be storage allocations, network management, everything, every management should be processed through the kernel. So why we are installing the operating system? So to make a clear understanding for the user. This is for the user purpose, not for the hardware purpose. Whatever you are seeing here, whatever the OS that we have created, this OS is for the user purpose. But the kernel, whatever the kernel is there, this kernel is for the hardware purpose. Why? Because the hardware understandable language is not a user language. What is the hardware understandable language?
Binary.
Binary language. Okay. So the hardware understandable language is the binary language that cannot be interpreted by OS. So who will compile the OS request? The compilation will be done by the kernel. So kernel will send the request, and whatever the request the hardware gets, it will send back to the kernel, and it will interpret back to the OS, and that will be visualized to the user. So that's how it works. So if you see the, do you know the history of Linux? Have you ever heard the history of the Linux? Is Linux is a OS or a kernel? Search in the Google and tell me very fastly. I think you have the internet. Search is Linux is kernel or OS. Search it fast. Yeah, time up. Can you tell me, is the Linux is an OS or kernel? It's a kernel. Like Unix is not a OS. So sorry, Unix is not depending on the Linux. We'll come back to that later. But Linux is a kernel. Sir, how can you say that, sir? We are having so many flavors of Linux. So here is the very important concept is that in 1980s, if you go back to the 1980s, I don't want to discuss all these things here in the Docker and all the things, but I just want to make sure that you will understand a few points. Why? Because kernel is very important. So whatever the containers that we are discussing, the containers doesn't require the kernels. They will work on the host operating system kernel. What is that? We will discuss about that. It's a little bit confusing for you. So first of all, let me discuss you about this Linux evaluation, and then we will discuss back to the containers. In 1980s, so who there is Kem Thompson and Richard. So who has developed the Unix operating system? So after developing the Unix operating system, they sold the Unix operating system. They did not give it for free. Whatever the Unix operating system that you are seeing, that is not free. Okay. Now what happened? There is a person with the name Richard Stallman. So there is this guy called as Richard Stallman. So he has opposed that. Already we are purchasing the hardware. Already we are purchasing the hardware. What is the necessity of going with the software? So he has developed a new operating system around 1985, 1982, 1985. He has developed a new operating system called as GNU. No. So there is no abbreviation for that. Okay. So GNU, not Unix. So that is what he will say. There is no abbreviation for GNU. He has developed that operating system. So when he is developing the operating system, he has developed everything, but he failed to develop the kernel. So without kernel, operating system will not work. So a kernel is the backbone for your entire operating system. Kernel is the backbone for your entire operating system. So without this kernel, how operating system will work? So he has stopped the what I can say, creating that operating system. Later on 1990 or 1991, there is a guy called as Linus Torvald. He has discovered this Linux kernel and attached that to the GNU operating system. When he attached that to the GNU operating system, a new version of operating system came into the world, GNU Linux, which they have sold, not sold, which they have given for the free of cost. It's an open source operating system. So in general, Linux is a kernel, and later on the base on the top of that, they have developed so many flavors like Red Hat, SUSE, Parrot, Ubuntu, and Debian. In Debian, you will have the Kali Linux, CentOS, like that. There are so many things that has been introduced into the market. Somewhere around now 1000 distributions are available. So in Linux we don't call it as OS, we will call it as a distribution. So somewhere around 1000 distributions are 1000 and more than 1000 distributions are available in the market. So how and why? Because it's a open source code, everyone can change the Linux operating system. So altogether it's a different concept that is not related to our Docker and container. Now that much important is the kernel. So without kernel, what happens? Your operating system functionality will not be there. It will not communicate with your hardware. So, but the containers, whatever we are creating, doesn't require the kernels. But the Windows operating system, whatever the virtual machines that you are seeing here, the application will communicate with the guest OS kernel and they will work. So the kernel will provide the resources to them. But when you come to the containers here, the containers doesn't require the kernel at all. So they can work without kernel also. How? So that's the 1000 marks question here that we will discuss in the next session. Why kernel is required? What is the necessity of the kernel? Without kernel, can't a container will run? Yes, container will run without kernel. But you have said that without kernel, management will not happen. Resource management will not happen. Then how containers will manage the applications? So inside the virtual machines, your applications will be running. The same applications you can run in the containers also. But the application has to communicate with your operating system to run. But in the container, you don't have a kernel. Then how the applications will run? So that's a 1000 marks question here that we will discuss in the next session. I hope you understand today's session. Any questions before I go into the particulars about the batch and the batch timings and duration and everything? Technically, do you have any questions? Okay. So no questions, everyone. Fine. So this is the Docker and Kubernetes session, as you all know about this. And you can ask me, sir, what is the syllabus? There is a lot of syllabus, and I will give you in the next session the syllabus also, Docker syllabus and Kubernetes syllabus. Or else you can go to the DURGASOFT website also, you can check out that syllabus over there. So the class timings will be at 8 p.m. IST. Okay, so whoever are coming from the other parts of the world, you can also adjust your time as per this. So 8 p.m. IST will be the time, and the duration will be 40 working days. That is from Monday to Friday. Every day, 1 hour of session will be there. 1.5 hours of session will be there. And what else? Regarding the fees, I think already DurgaSoft has given you the thing. So how much fees you have to pay for that, and please provide your proper numbers for the DurgaSoft. Don't give like single digit number or double digit number. So it is mandatory to provide you the proper number so that we will contact you and you can share the feedback also. Okay. So that's about the concepts which we are going to discuss here. So that's all for today. So if you have any questions, you can post me now.
Sir, if you have any Visa card payments available?
Yeah. So that you can contact the DurgaSoft. They will give you the proper requirement things for you. Everything is available from their end. You can contact them. They will give you the details. Okay.
Yeah, I want to contact. Sir?
Sorry.
Where I want to contact to.
Yeah. I think they have given you the number also in the chat.
Yeah, I'm from basically Sri Lanka. Sri Lanka doesn't have a Google payment, so any
No,
other
no.
methods.
You, you can contact them through the mobile. So this is the mobile number 8896979797. You can
Yes.
contact them. Okay. So they will give you the response for that. Or else you can, if you got any email, just reply to that email so that they will contact you.
Okay.
Okay, guys. So then I hope I made it very clear for you. So if you have any questions or also anything, we'll discuss in the next session also. Next session also, you will have the same free Zoom session only tomorrow, also tomorrow and day after tomorrow. And after that, we will have the paid sessions. Okay. Have a nice day and we'll meet in the next session. Bye.